approach to accelerate the development. Okay, and there's another image here I can bring up too, slightly closer shot of the rocket. And designed to eventually be fully reusable, Starship stands 397 feet, or 121 meters tall, with both stages combined, 90 feet taller than the Statue of Liberty. Its super heavy booster produces 16.7 million pounds, or another way of putting it, 74.3 meganewtons. I think we can all relate to that one, of thrust, almost double that of the world's second most powerful rocket. NASA's Space Launch System, though the latter is now certified, while Starship is still in a prototype phase. And there's one more image here of the rocket actually launching in its arc across the sky there. Starship's third launch test in its fully stacked configuration was its most ambitious yet, and the company said it was able to meet many of its objectives. These include opening and closing Starship's payload door to test its ability to deliver satellites into orbit and its first atmospheric re-entry. High-definition footage from an onboard camera showed Starship's coasting in space, with the curve of the Earth visible in the background. It hit a top speed of more than 26,000 kilometers per hour and achieved an altitude of more than 200 kilometers above sea level. Starship flew halfway around the globe, then began its descent over the Indian Ocean, with engineers cheering as its heat shield glowed red hot, which we all saw in the 6 o'clock news tonight. But ground control stopped receiving signals 49 minutes into the flight and declared the vessel lost, probably destroyed, before it could achieve a planned hard splashdown. The lower stage booster also failed to make a successful water landing, and as a result, the Federal Aviation Administration said it was opening up a mishap investigation. Starship will make life multiplanetary, Musk, the company's billionaire founder, posted on X, afterward emphasizing the progress made. The first so-called integrated test came in April 2023. SpaceX was forced to blow up Starship within a few minutes of launch because the two stages failed to separate. The rocket disintegrated into a ball of fire and crashed into the Gulf of Mexico, sending a dust cloud over the town several miles away. The second test in November 2023 fared slightly better. The booster separated from the spaceship, but both then exploded over the ocean in what the company called a rapid, unscheduled disassembly. It currently costs SpaceX around $90 million to build each Starship, according to a report by the research company Payload published in January. SpaceX's strategy of carrying out tests in the real world rather than in labs has paid off in the past. Its Falcon 9 rockets have come to be the workhorses of NASA, or for NASA, and the commercial sector. Its Dragon capsule sends astronauts and cargo to the International Space Station, and its Starlink internet satellite constellation now covers dozens of countries. But the clock is ticking for SpaceX to be ready for NASA's planned return of astronauts to the Moon in 2026 using a modified Starship as their lander vehicle. China is approaching in the rear-view mirror, targeting 230, that is to say the year 2030, to land its first crew on Earth's nearest neighbour. Not only does SpaceX need to prove it can launch, fly and land Starship safely, it must eventually also show it can send multiple Starship tankers into orbit to refuel or supercooled temperatures, a main starship for its onward journey to the moon. So there's more to that story, but and there's more to the story still to come, I would say. But certainly Elon Musk's bank account must be pretty big, one way or another. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular broadcast here on Friday nights. The next thing I was just going to bring up was on also courtesy of the Space Exploration Facebook page. Citizen astronomers and AI discover 30,000 ring galaxies by the Subaru telescope, March 14. Building on the synergy between citizen astronomer classifications and AI, artificial intelligence, astronomers have discovered approximately 400,000 spiral galaxies and 30,000 ring galaxies in data from the Subaru telescope. And this is the first example of research building on the classification data from citizen science project Galaxy Cruise. And I'll just bring up the image that they've got here of all this. There are, I'm going to go to see more. Alright, so in this image here you're seeing spiral and ring classifications for bright galaxies. Let me read a little bit of this article first. Galaxies display a wide variety of morphologies that reflect their histories. Data sets from powerful cutting-edge facilities like the Subaru telescope contain so many galaxies that astronomers cannot classify them all by hand. In the Galaxy Cruise Citizen Science Project, professional astronomers asked more than 10,000 citizen astronomer volunteers to do the classifications. But even divided among thousands of volunteers, classification still takes time. AI can conduct classifications quickly, but first it needs to be trained on a catalogue of classifications and examples prepared by humans. For this new study, a team led by Rhythm Shimakawa, Associate Professor at the Waseda University, trained an AI on a set of 20,000 galaxies classified by humans as part of Galaxy Cruise. The team then turned the AI loose on all 700,000 galaxies in the Subaru telescope dataset. The AI classified 400,000 of them as spiral galaxies and 30,000 as ring galaxies. Even though ring galaxies account for less than 5% of all galaxies, this research yielded a sample large enough for meaningful statistical analysis. An AI algorithm trained on approximately 900 ring galaxies selected by Galaxy Cruise was able to find over 30,000 ring galaxies. And of course the role of Galaxy Cruise in this research and further prospects, although AI classification takes less than 1 hour, even for 700,000 galaxies, and this work cannot be done without the data collected by Galaxy Cruise over the past 2 years. We would like to thank all citizen astronomers who participated in the project. And the bloke here says that I hope to see more collaborative outcomes in the future. Yeah, citizen science, I reckon, is a pretty cool thing when something gets organised, that you can use your computer at home to be able to get involved with these sorts of projects, which is really fantastic. Fantastic, isn't it, Dennis? That's fantastic. All right, where are we? Next thing I was going to bring up, also courtesy of the space exploration page, which I thought was interesting. Surprising insights about debris flows on Mars, March 14. The period that liquid water was present on the surface of Mars may have been shorter than previously thought. Channel landforms called gullies, previously thought to be formed exclusively by liquid water, can also be formed by the action of evaporating CO2 ice. And we have a picture here of this. Whereabouts is this picture? There it is. There she blows. Continuing on with the article. CO2 ice. That is the conclusion of a new study by Leonki Rorofs, a planetary researcher at the Utrecht University. This influences our ideas about water on Mars in general, and therefore our search for life on the planet. The results of the study are published this week in the journal Communications, Earth and Environment. The Martian atmosphere is 95% CO2, Roloff explains. In winter, air temperatures drop below minus 120 degrees Celsius, which is cold enough for CO2 in the atmosphere to freeze. In the process of freezing, CO2 gas can change directly to CO2 ice, skipping the liquid phase. The process is similar to frost on Earth, where water vapor forms ice crystals and blankets the landscape with a white film. Warmer spring temperatures combined with the thin Martian atmosphere cause the CO2 ice to evaporate directly back to gas, again skipping the liquid phase. We call that sublimation. The process is extremely explosive due to Mars's low air temperature, or air pressure, I should say. The created gas pressure pushes sediment grains apart, causing the material to flow, similar to debris flows in mountainous areas on Earth. These flows can reshape the Martian landscape, even in the absence of water, and this is what you're basically seeing on the screen at the moment. The results of the research suggest that the chance of life having existed on Mars is smaller than previously thought. Scientists have hypothesized that CO2 ice could be a driving force behind these Martian landscape structures, but those hypotheses were mainly based on models of satellite studies, Roloff explains. With our experiments in a so-called Mars chamber, we were able to simulate this process under Martian conditions using the specialized lab equipment. We could directly study this process with our own eyes. We even observed that debris flows driven by CO2 ice under Martian conditions flow just as efficiently as the debris flows driven by water on Mars. And we have a picture of this chamber with Leone, what's the name again? Leon Roloff, something like that, Roloff. So, we know for sure that there was once water on the surface of Mars. This study does not prove the contrary, Roloff says, but the emergence of life likely needs a long period where liquid water was present. Previously, we thought that these landscape structures were formed by debris flows driven by water because of their similarity to the debris flow systems that we see on Earth. The researcher says that my research now shows that in addition to the debris flows powered by water, the sublimation of frozen CO2 can also serve as a driving force behind the formation of these Martian gully landscapes that pushes the presence of water on Mars further into the past, making the presence of life on Mars smaller, and that makes us even more unique than we thought. So yes, there's in this image here is Leonki Leoniki Roloffs, I think that's how you pronounce the name, next to the Mars Chamber at the Open University at Milton Keynes in the UK. What a clever girl. Okay, so our next article, and I'll just bring back the camera. Okay, and the next thing I was going to bring on here that I thought was interesting to mention, where are we with this? Just going down the page. Oh yes, okay, this one here. And I won't read this entirely out. This is quite a bit of writing here. But what can we learn flying through the plumes of Enceladus? In the next decade, space agencies will expand the search for extraterrestrial life beyond Mars, where all our astrobiology efforts are currently focused. This includes the ESA's Jupiter Icy Moon Explorer, or JUICE, and NASA's Europa Clipper, which will fly past Europa and Ganymede repeatedly to study the surfaces and interiors. There's also NASA's proposed Dragonfly mission that will fly to Titan and study its atmosphere, methane, lakes, and the rich organic chemistry happening on its surface. But perhaps the most compelling destination is Enceladus and the lovely plumes emanating from the southern polar regions. And I shall just bring up this image here of this study, hope to be done. You can see the plumes in one image there at the bottom. That little black and white image is actually an image of these plumes venting into space. Since the Cassini mission got a close-up look at these plumes, scientists have been aching to send a robotic mission there to sample them, which appear to have all the ingredients for life in them. This is not as easy as it sounds, and there is no indication flying through the plumes will yield intact samples. In a recent paper published in Meteoritics and Planetary Science, researchers from the University of Kent examined how the velocity of a passing spacecraft and the resulting shock of impact could significantly affect its ability to sample water and ice within the plumes. The research was conducted by Professor Mark Burchell and Dr. Penny Wardensisk, it's a Polish name, from the Centre of Astrophysics and Planetary Science, part of the School of Physics and Astronomy at the University of Kent in the UK. Their work could have significant impacts or implications for mission of icy ocean worlds, bodies in their outer solar system composed predominantly of frozen water and volatiles with oceans in their interior. These bodies have become of increasing interest to scientists since it's possible some could support life. The term ocean worlds has become common in recent years as the number of potential candidates for exploration has increased. Since the Voyager probes passed through the system in 1979, scientists have speculated about the possibility of an interior ocean within Europa based on its surface features, and this includes patches of young terrain sitting next to older created terrain, indicative of regular exchange between the surface and interior. The Voyager probes noticed similar youthful terrain on Enceladus when they flew past Saturn in 1980 and 1981 respectively. And below this image that you're seeing here is an artist's rendering showing an interior cross-section of the crust of Enceladus, which shows how the hydrothermal activity may be causing the plumes of water at the moon's surface. Very interesting place to go and investigate. Alright, I think I'll leave that. Thanks to Kate Green for the wonderful work she does with the space exploration page on Facebook. Very good. Alright, this is VK3EKH ASV Radio. On behalf of the Astronomical Society of Victoria, we say a very pleasant good evening to Cassiopeia, Nebs and Robert, VK3GOD, Dave, VK3KDM, and also Richard, VK3VRS, and they're on the Discord channel as we speak. So good day to you chaps. And I think we have Andrew, VK3KIS, checking in. G'day Andrew. And the Wayne Factor. So, noisy band. Yes, I agree. Actually, I've got some local noise here tonight on 80 Meds. I don't know how well I will go at listening, but there's some horrible switch mode noise that's going up and down the band. I went around turning things off before thinking it was something here local, but I couldn't seem to isolate it. So, yeah, a bit of a nuisance factor, that one. Alrighty then, so the next thing we have here at 10:30 approximately. How does a black hole, and I must admit, I have often thought this, how does a black hole get to the centre of a galaxy, and does the galaxy revolve around it? Yes. We'll answer that one next week, I think. No, I won't do that. Alright, there is a artist's impression here, of course, so I shall throw that up on the screen, on the visions, and I might bring in my little sidereal camera. There it is, because it's working. I like it. Alright, okay. There are three types of black holes, in case you didn't know that, all born in different ways, but even the largest black hole can't dominate the rotation of a galaxy, it seems. If a black hole begins as a star somewhere in a galaxy, how does it end up in the galaxy's centre? Is the gravitational pull so strong that all the stars in the galaxy start revolving around it? Is the question asked by Paul Simon, North Carolina. Answer to this is that the black hole created by a single star's death is called a stellar mass black hole. These black holes have masses about 2 or 100 times that of the Sun. When a star explodes to create a stellar mass black hole, it might give itself a little kick and start flying through space. But this kick is random and could send it inward, outward, or in any direction in 3D. So these black holes don't tend to end up in a galaxy's centre unless the star that created them happened to be there. The type of black hole that's sitting at the centre of a galaxy is different. This is a supermassive black hole, or an SMBH, and as its name implies, it's much heftier. SMBHs have masses of at least 1 million solar masses, up to several billion solar masses. The one in the centre of the Milky Way is about 4.3 million solar masses, while the one in the centre of the elliptical galaxy M87, for instance, is more like 6.5 billion solar masses. And there's another little image here that they've got. I'll just throw that into the mix because it's part of the article. SMBHs, or actually, before I start reading these next two paragraphs, the image on the screen right now, and I might just remove my insert there, which is this one here. In this on-screen image at the moment, the supermassive black hole depicted at right in this artist's concept in the centre of a galaxy only has enough gravitational pull to influence the closest stars, shown as the white dots circling the black hole. It's the right side image. For the most part, the entire galaxy left rotates around its center of mass rather than the black hole. SMBHs are not born the same way as stellar mass black holes, nor do they seem to be typically made up of many smaller black holes or smooched together. In fact, we don't entirely know how SMBHs are born, but we do believe they arise roughly around the same time a galaxy is assembling itself, and we know that the two evolve together over time. But while they can influence each other, the gravitational interactions between an SMBH and its host galaxy are very minor. Just because the SMBH is sitting in the center of a galaxy doesn't mean all the stars are revolving around it. Even with its super hefty mass, an SMBH may only account for some 1/millionth the mass of the galaxy as a whole. That's such a tiny fraction that the stars in the galaxy barely even know the SMBH is there, gravitationally speaking. Plus, the strength of gravity falls off incredibly quickly and the farther you get from the black hole. So only stars that are close to the black hole will orbit it. The vast majority of stars in a galaxy orbit the center mass of the galaxy as a whole, which is also in the center, but it's not actually the SMBH, solar mass black holes. Righto, courtesy of astronomy.com. There you go. Always wondered about that. It was one of those little questions that you'd ask, thinking it's a silly question to ask, but it's not so silly. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, the regular Friday night broadcast. Incidentally, the 15th of March is the peak of the Gamma Normid meteor shower. The Gamma Normids meteors peak around the 15th of the month today, and they are centered near the star Gamma Normae, the third brightest star in Norma, which lies between Scorpius and Centaurus. They are a minor shower and would be best to look from midnight to dawn from a dark sky location. Just thought I'd throw that one in. Righto. What are the smallest stars? The James Webb Space Telescope has a new answer. And I'll bring up the image that is associated with this article. And I'll throw in my little insert. Meet the newest featherweight champion, a tiny, free-floating brown dwarf about 300 times smaller than the Sun. One basic question you'll find in every astronomy textbook is, what are the smallest stars to exist in the universe? ? That's what we've been trying to answer, said lead author of the new study, Kevin Luthman of the Pennsylvania State University. This past December, the high sensitivity of the James Webb Space Telescope helped an international team identify the new record holder, a tiny free-floating brown dwarf with only 3 to 4 times Jupiter mass, about 300 times smaller than the Sun. Brown dwarfs are objects that blur the lines between what differentiates a star from a planet. They form just like stars when a dense cloud of gas collapses into itself from strong gravitational force, but never reach the required minimum of temperature or density to begin fusing and becoming luminous, earning themselves the nickname failed stars. Dwarfs are smaller than low-mass stars, less than 2 solar masses, but can be up to 70 times Jupiter mass and have planet-like atmospheres. The research team targeted the star cluster IC348 for its relatively young age, less than 5 million years old, and its rich population of about 500 members. Because it's a star-forming region lying around 1,000 light-years away in Perseus, any new formed brown dwarfs are still glowing in infrared light from the leftover heat of their formation. The James Webb Space Telescope's near-infrared camera captured 3 brown dwarfs ranging from 3 to 8 times Jupiter mass and 830 to 1500 degrees Celsius in IC348. The team was able to determine the mass of the smallest brown dwarf through computer models, but how a tiny brown dwarf could have formed from a small cloud of gas in the environment with weaker gravitation remains a true puzzle. Once this is understood, astronomers will have a better understanding of the star formation process, they say. That's the only image I've got there. So this image on the screen, it's an image of the star cluster IC348 captured by Webb's NIRCam. So it's a real image, what you're seeing there, although the little box insert that you see there is this brown dwarf that they're talking about. Since brown dwarfs straddle the definition solely for stars and for planets, Luhmann's team was also able to expand the current understanding of exoplanets. Out of the entire survey taken, the chemical signatures of 2 brown dwarfs stood out for having a molecule containing both hydrogen and carbon atoms, simply called hydrocarbon. Hydrocarbon is present in the atmospheres of Saturn and its satellite Titan and in the interstellar medium. But this is the first time we've detected this molecule in the atmosphere of an object outside our solar system. Current models do not support the existence of these brown dwarfs, which leaves astronomers second-guessing whether or not these objects are indeed brown dwarfs, and instead are ejected rogue exoplanets. But despite the doubts, such planets existing is quite uncommon and unlikely given the star cluster's age, so astronomers are still Team Brown Dwarf. Further studies and longer, more extensive surveys should help advance the quest for finding the smallest brown dwarf, as well as the understanding of the formation processes of stars and planets. Thank you, Astronomy.com, for that article. Okay. Now we go to Astronomy.com at 19 minutes to 11. Deep space, I won't read this all out, I'll just make it a appetizer. This is published 2 days ago. Deep space astronomy sensor peers into the heart of an atom. And there's a picture here too. Bring this up. Right, that'll do. Developed initially for space observations, the Compton camera has now proven its worth as a tool for addressing complex scientific questions in other domains as well. And the picture on the screen here, on the left is the Compton camera, COMPTON, originally designed to investigate the universe on cosmic scales. Scientists have taken an instrument originally designed to study huge celestial objects in the cosmos and repurposed it to investigate the world on an infinitely smaller scale. With this instrument, they managed to probe the heart of the atom. The team wanted to understand quantum scale changes that occur within unstable atoms, and realized there's a state-of-the-art gamma-ray polarimeter they could tap into. Polarimeter, perhaps? This device, known as a Compton camera, can measure the polarization of high-energy light waves. In other words, it can dissect what direction such high-energy light is orientated toward. The only thing is, however, that this instrument was technically built for deep space astronomy, not atomic investigations. In fact, scientists constructed it because they wanted to place it on the Hitomi satellite to make observations of high-energy cosmic processes. Yet the camera has now proven its versatility by capturing the polarization of gamma rays emitted from atomic nuclei. Rather than faraway galactic objects, it managed to reveal the internal structure of the atomic nucleus as well as any changes such nuclei may be undergoing. The Compton cameras are used to determine the direction of energy of gamma rays through a phenomenon called Compton scattering. Compton scattering happens when a high-energy particle of light or photon bounces off a charged particle, usually an electron. This interaction forces the protons hitting the electrons to scatter, meaning they transfer some of their energy and momentum to the particles we've just hit, or they have just hit. In turn, those electrons can recoil and essentially pop off the atom they were previously attached to. This process can help reveal something about the atom that's involved. The research team demonstrated that this Compton camera serves as an effective polarimeter for nuclear spectroscopy (PPP), revealing insights into the nuclear structure. Right, and that now continues on to a much bigger article, which I shan't read. But that was just a whet your appetite thing. So if you want to catch up with the rest of that article, it's space.com. www.space.com. Look under the heading of space. Look under the heading of technical. Deep space astronomy sensor peers into the heart of an atom. Righto, and finally, last article for tonight. Might actually finish before 11 o'clock. Let me go back to this one and get rid of that for a moment. Okay, we want to bring up this picture here. And I'll bring back my insert again. Alright, so in the final article for tonight, Earth received a message laser beamed from 10 million miles away, and there is actually a short video attached to this article, which I will play. It only goes for a couple of minutes when I get to it. Okay, 15th of March, this was published. Eventually, we're going to want to expand the World Wide Web across the galaxy, and NASA recently demonstrated a key piece of tech that could help beam messages via laser across a distance of almost 16 million kilometers. That's about 40 times farther than the Moon is from Earth, and the accomplishment achieved in November 2023 represented the first time that optical communications have been sent across such a distance. Traditionally, we use radio waves to talk to distant spacecraft, but higher frequencies of light, such as near-infrared, offer an increase in bandwidth and therefore a huge boost in data speed. If we're going to eventually be able to send high-definition video messages to and from Mars without a significant delay, then this is a step towards the tech we need. The test was part of NASA's Deep Space Optical Communications (DSOC) experiment, and the successful establishment of ComsLink is known as First Light. Achieving First Light is one of the many critical DSOC milestones in the coming months, paving the way toward high data rate communications capable of sending scientific information, high-definition imagery, and streaming video in support of humanity's next giant leap. Trudy Courts, who is Director of Technology Demonstrations at NASA's headquarters, said, "We all rely on similar tech built into fiber optics for our ground-based high-speed communications, but here it was adapted for use through deep space to improve on existing methods of getting information back to Earth. Being infrared light, engineers can easily transmit its waves in a laser form. This won't get the light moving any faster, but it does tidy and constrain its beam to a narrow channel. This requires far less power than a scattering of radio waves and is harder to intercept. That doesn't mean it's a simple task. Data bits are encoded in the photons emitted by the laser, which requires a number of heavy-duty instruments including a superconducting high-energy detector array to prepare the information for retransmission and translate it at the other end. Another challenge is having the system adapt its position and configuration in real time. In this latest test, the laser photons took about 50 seconds to get from spacecraft to telescope, and both were hurtling through space while this was happening. The laser transceiver that made the connection is on board the Psyche spacecraft, that's what it's called, which is on a years-long mission headed for the asteroid belt between Mars and Jupiter. It made contact with the Hale telescope at the Palomar Observatory in California. Psyche, Psyche, is scheduled for a flyby around Mars, and so tests will continue to be carried out to refine and improve this innovative near-infrared laser communication method and make sure it's as fast and dependable as it needs to be. It was a formidable challenge, and we have a lot more work to do, but for the short time, we were able to transmit, receive, and decode some data, said Mira Serinzvi, that word, DSOC Operations Lead, NASA Jet Propulsion Laboratory. Yes, there it is. So, alright, let's just squirt over to this short video. And let's just see how this plays. It's just a short video, so it doesn't get very long, but it's part of this article. And I think what I have to do is press that button there, and we should have something happening. So let's stand by.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, to have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance, and Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
Okay, so that was... there's me on, that's the repeater up there. So I had to juggle audio levels there, as I normally have to. So I think I've got the normal level back here for HF and for TV. So yes, all very interesting what's happening with Psyche. And we'll keep in tabs with that and see what transpires certainly when it gets to Mars. I think if they can establish laser communications, it'll be quite interesting to see how successful that is. All right, coming up on 5 minutes to the hour, let's pick up spaceweather.com. Testing 1, 2, 3. The sun. This is the current disk of the sun as we speak, and there are approximately 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, 7 sunspots designated on the surface of the sun facing us at the moment. The solar wind is currently at 396.2 kilometers a second. We're at a density of 1.45 protons per cubic centimeter. And just making sure my levels are right here for HF. And the sunspot number is currently 88. The radio sun, measured at a wavelength of 10.7 centimeters flux, is 128 solar flux units. The KP index, planetary K index, currently at the moment is 2. KP is equal to 2.00, which is considered quiet. The 24-hour max is equal to 3.67, which is also considered quiet. The current auroral glow over Antarctica looks like this at the moment, so it's not very strong. There's the usual glow, but nothing to write home about, as I always say. And otherwise, there's not much else to report out of spaceweather.com. There's been the vernal equinox is only in four days away, according to this. That's good news because auroras love equinoxes. Research call it the Russell-McPherson effect. At this time of the year, cracks form in Earth's magnetic field. Even a weak CME or stream of solar wind can penetrate to spark a good display of auroras. So things are afoot. What else? Going down the page. Yep, not much else to report really. Near-Earth asteroids, potentially hazardous asteroids, are space rocks larger than 100 meters that can come close to Earth by 0.05 AU, but none of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time, they say. On March 15, 2024, there were 2,349 potentially hazardous astronauts. Asteroids, that is. Potentially hazardous astronauts. Oh yes, go look out for them. All right, I think that's about it for tonight. Let's finish up here nicely at 11 o'clock thereabouts. All right, looks like everything's hung in there tonight. The YouTube stream is still purring along nicely. I hope I haven't had too much in the way of audio distortion on YouTube. I've got to keep an eye on that. All right, let me see. Just connect my headphones, find a pencil, and let's just do a quick call on 3541 for any stations wishing to check in for tonight. This is VK3EKH listing 3541.
Golf Lima. VK3 Delta X-ray. VK3 Bravo Sugar Foxtrot.
Okay, VK3GL, VK3JR, VK3DX, VK3BSF. Anybody else? And VK3GOD, I think it was. Not a very strong signal compared to everybody else there, but I'm pretty sure that was you, Robert. All right, let's go across to Graham, VK3GL, VK3EKH.
VK3EKH and the group VK3GL. Good evening to everyone else who checked in. Copied all stations. 3GOD was down as observed, collecting signal strength to me as well. Anyway, very pleasant good evening to you all. Just had a bit of a, well, look, I've listened to 2 or 3 of your articles tonight there, Clint. Unfortunately, work has been a tad on the busy side, so I've been sort of going from listening to your YouTube broadcast and feed to work and then back to so it's been all very disjointed. One of the things I did have a chuckle about too was the hazardous astronauts. That was quite funny. Anyway, look, thanks for the broadcast. I know that you had some good articles there tonight. I wish I could have seen more of them a little more completely than what they were. Unfortunately, that's the way that it goes. But good signal on 80 metres too. Ripping signal, in fact, most of the time nearly 30 over 9. So a really form strong signal this evening there, Clint. May have a few words after you've done your check-in rounds anyway. I'm finishing work a bit after midnight, so may have a few words if time permits. VK3EKH and the group VK3GL.
Yeah, no worries, Graham. VK3GL, VK3EKH. Yes, I know that you're doing your work there from home, so that can be of course got to concentrate on that. But anyway, thanks for calling in. Good signal from you. You're about 30 over, so not a problem at all. And so I have to laugh at myself when I trip over words. It's can't be taken seriously, really. Anyway, thanks, Graham. No problem. I may be around for a little while after. I think Dennis might want to come up as well, perhaps. So we'll see. Across to Frank, VK3JR, VK3EKH.
VK3EKH, VK3JR. Good evening, Clint. Good evening, everyone else. Just excuse me. I'll just turn to a minute. Yes, look, I had some interruptions, but what I heard was very interesting, as usual. Thank you for doing it. And I don't have any special... the solar news is interesting. The average that we're getting around about the last month or two has been lower than what we were getting last year. So maybe we have peaked. Maybe we've peaked, Clint. I don't know. But it's not boding too well at the moment. A pretty low sunspot number compared with what we've been having, up to 150 and that sort of thing. What time will tell. Otherwise, there will be missions if you're interested after you speak to your post-broadcast people. And look forward to talking to you next week. Thanks again for doing it, VK3EKH, VK3JR.
Yeah, no worries, Frank. Lovely signal from you tonight. VK3JR, VK3EKH. You're hovering around 20 to 25 over. It's quite nice copy indeed. And I'll switch over to 160 when I'm finished here for sure. I'm still working on my other receivers here in the shack. Like the AR7 and a few other receivers that usually I have on 160 all the time, is still in a bit of a disconnected state. I remember saying last week that in the camera view on air at the moment, there's a rack, 6-inch rack behind me, 6-foot rack, 12-inch, 19-inch rack. That's what I'm trying to say. And and there's a whole bunch of equipment that I want to screw in that rack. It's all under the bench here, and my knees keep bumping on the blasted stuff. So I was hoping to do that last weekend. It was a nice long weekend, but do you think I got around to doing it? Nope. So either this weekend or perhaps the Easter weekend, maybe, perhaps. We'll see. But anyway, nevertheless, we shall tune across to 160, and I'll probably be up on the coffee break net tomorrow morning. Only the two of us, most likely. But we'll see if Steve comes up, if he's in the shack in the morning there to talk to Gus. So yeah, enough of that. All right, thanks, Frank. Greg, VK3 Delta X-Ray, VK3 EKH. Did you get a chance to go to the Messier Star Party? Did you roll up at that? Apparently, it was a very successful get together. The town of Hamilton absolutely welcomed the ASV being down there last weekend, and from what I've read thus far, it's been quite a successful turnout, and so much so that there are plans afoot to bring astronomy to the to some of the schools, one or two of the schools down there, bring astronomy basically. But that all stemmed from the activities of last weekend. So and the skies apparently turned on a show for the Messier Star Party, which was really good. VK3DX, VK3EKH.
Colleges there in Hamilton, so, and I know one of them had a radio club there at one stage, and it still has the license, but I don't think it's been activated quite a number of years. So yeah, I'd imagine Hamilton College Electric is the one there, Clint, but there's another one up there too, Monterey, and a couple of quite So you have a lot of borders there from surrounding areas, so yeah, it could be interesting there, Clint. Long weekend. Yeah, not long enough, mate, that's the problem. But last weekend was still extreme, temperature-wise, so it's almost didn't handle the heat very well. And still recovering from the hip operation. And this week there last Tuesday, so it's all still coming along okay. Good evening, Graham, thanks, and Robert. All good signals. Robert, COD was a little bit down, but I heard you there, Robert. All good, mate. And thanks for running the broadcast here, Clint. Another interesting broadcast, as you do every week, and we appreciate it. You do that for us. Okay, mate, I think that's a long enough transmission. Your signal is 5 plus 20. 9 plus 20, and audio sounds good. Interesting your comments about 160. The band I haven't operated on. I come into amateur radio when a friend of mine, he was a 160 metre operator down here. That was back in the old AM days, and we were using the old AT5 and what you mentioned, the AR7 and 8 and all that stuff. All that stuff was here, but anyway, back in the AM days, we're going back a bit. I've got an antenna, I've got a So I have to work out whether I can put it up on the, well, I've got this other antenna up and then bend at right angles down the bottom end and take it around a bit. So that'll give me 160 through the 10 metres. So that may be a challenge in the future, but I'll be fix in the future. So I hope Frank's not right about the cycle. Engineer, I've got a lot of things to do. But I may not be around to the next cycle, so I'm thinking I'm doing everything I want to do in this cycle. Anyway, that's a long overthink. Okay, 3KH. Thanks for running the net there, Clint. You're doing a marvellous job. Okay, 3 Delta X-ray, Greg Immortable.
Thanks, Greg. VK3 Delta X-ray, VK3 EKH returning. And yes, you're hovering somewhere between 15, 20 over. A little bit of QSB on the signal, but otherwise coming through quite well. Yeah. Right. Yes. I was just trying to find the feedback about the last weekend's thing. You're quite right. It was a very hot weekend. Not really conducive of being outdoors during the day. But since astronomy generally happens at night time, where things do cool down, so well, sort of cool down. I still hovered around 29 degrees even during the night last week. But still, they had a good time, and I was just trying to see any references to the school that apparently that's of interest, but I'm not really seeing this article right now. Or not so much an article, but just a report from I think it was from the president of the ASV, who wrote a comment answering a question, but I cannot see it quickly enough, so I won't worry about it. But suffice to say, what came from last week was very successful. The ASV is actually out at Gippsland this weekend. They're calling it the Buchan. They're out of Buchan, as far as Buchan in far east Gippsland. And it's a small star party of some sort that's running this weekend, and the folks are already up there setting up. So I don't know whether there's any amateurs that have got radio equipment going and that might be listening to me, but send us an email if there is. If there's anybody out at the Buchan Star Party get together this weekend, so be interesting to see if there is. All right, 160. Yeah, look, I'm still an antenna down for getting up on 160 at this time of the night. As you may remember, I used to simulcast the broadcast on 160, and I still want to get back to doing that on 1865. But the main antenna that I use for 160 is tuned for 1825. And it's not advisable to come up on 1825 during the night unless you're a CW station. So I would like to have a second antenna that I can switch to for 160 to cover the high end of the band, predominantly 1865, so I can do the simulcast up there as well. So I must get around to doing something about that. Anyway, we'll see. But as soon as I start getting back on 160, I'll be announcing it here, of course. But meanwhile, no, I come up on AM 160 during the day a fair bit, and if I'm home, I'll be joining the coffee break net at 11 o'clock in the morning on weekday mornings, which generally spills over to Saturday morning as well. All right, thanks, Greg. Peter, VK3BSF, VK3 EKH. Good evening, sir.
Good evening, Pete. VK3BSF returning. Good signal and good broadcast. You tripped over a few names there, and I think it's a bit hard to say some of those names. I think they're mainly the Indian names, which get a bit tongue twisted. There's a contest this weekend. Don't know if you're going to go into it and give a few numbers out, exercise the throat and the radio. I might just give a few numbers. It all depends. My 160 metre antenna doesn't want to work. It's there, but just a good lot of noise on it. Don't seem to receive much. It's sort of hidden around behind the back of the fence, so I guess it's covered with a bit of trees. I guess that's the problem. Always had a problem stretching it out to 160. I've got all my other antennas in the yard, and it gets in the road a bit. Otherwise, okay. Put it back to you. Good cast. Good broadcast. One of the most interesting ones I felt. It was very, very current. VK3 BSF. I've forgotten your call sign. VK3 BSF.
No worries, Peter. That's you're forgiven. There's two call signs floating around here. VK3CSJ, and I forgot to bring up my. Oops, that's the wrong one. Where's my insert thing gone? I've lost my text insert on the screen here. What's happened to that? Oh, that's that one. Oh. Maybe I should do that. And no, I'm just fiddling around with vMix here. And what's happened to my little floating thing? There it is. Okay, revolving banner. Oh, all right. Yes. Didn't know there was a contest this weekend, although I should, because I do the WI broadcast from here every Sunday, and it's at least 3 times in the one day that I hear the broadcast, and so if I miss something, I'll catch up with the next broadcast. But I do a broadcast of I do the WIA cast on 1825 Sunday morning, 9 o'clock, and actually last week I did the broadcast together with the ATV. Because it was going to be a super hot day, we've been very cautious of everybody who comes up on ATV. The word went out to try not to use the ATV repeater during the hot days, because the room up there at Mount View, where the repeater is located, apparently the air conditioning system is a bit sus, and it gets pretty hot in up there, and we didn't want to tax the repeater with long transmissions, so. The word went out not to use the ATV repeater during the hot weather. So my WI broadcast is 10:30 on Sunday mornings, and I decided to bring that back to 9 o'clock just to try and beat any heat. Although this weekend I think it should be okay, really, for all that. It'll still be a bit of a warm weekend, but not as hot as last week. So yes. What else was there in all that? Yes, 160. Okay. Pleasant good evening to Craig as well. Craig, VK3, what's your call sign again? Did I have it? It's there somewhere. KG, VK3KG, yeah. Craig sent me an email as well. Slowly losing my voice. All right, thanks, Pete. It's a good signal from you, absolutely. No problems at all. Robert, VK3GOD. You might need to turn your mic gain up. We'll see. VK3GOD, VK3KH.
Thanks for the broadcast. All very interesting this week. I didn't pop up last week because my radio was at Icon being repaired. But I received the map today, so here I am. Hope everyone has a good week ahead. I've just received delivery of the new smart telescope, so I'm eager to try that out. I might take it to Heath tomorrow night. VK3EKH, VK3GOD.
Oh, very good, Robert. VK3GOD, VK3EKH. Is that good signal that time? Good copy. Yeah, about 5 to 10 over 9. So just above that noise floor without too many problems. And I'm not suffering any noise there. It's all that interference that I had before seems to have gone away, thank goodness. Thanks, Rob. And yes, you're there on on Discord as well. So yeah, all very good indeed. The telescope you've just got. I've heard some good reviews on that particular telescope. So it'd be interesting to hear when you get the hang of using it. If you're how impressed you are with it. So future report, please. Yeah, but I've been reading a couple of reviews on it. It sounds like a pretty interesting telescope. All right. One more listen. VK3 EKH for any other stations there? Okay. All right. Thanks, gentlemen, for calling in tonight. Appreciate the call back. And we'll be back next Friday to do it all off again at 10 o'clock with more interesting reports and news items that come through every week. There is something new every week. There's always something happening in the field of astronomy that's worth reporting on. So on that, I shall conclude transmissions tonight. Cheers to Dave, VK3KDM, resident Mount Burnett Observatory astronomer. Like I say, if you live up in the hills, give Mount Burnett a visit. Mount Burnett's generally open on Friday nights. They meet up there at the cabin every Friday night, so you're more than welcome to pop in there as a visitor. And if the sky is clear, they will open up the dome. They've got a couple of domes up there now, and show you around. The observatory up there used to belong to the Monash University, and now there's a local community of very keen folks and astronomers that have taken over the observatory and maintain it. And like I say, every Friday night they generally meet. So just type in Mount Burnett Observatory in your favourite search engine to find out more information about that particular location. It's a 20-minute drive from here, and it's a nice little location. What else? Thanks, Cassiopeia. I hope the audio on YouTube wasn't too bad. I'll review it when I stop transmission. I'll catch up with it a little later on, and just hopefully it wasn't too badly distorted. And Richard's. I think, is it this weekend, Richard, that there's the plane and what is it? The plane and hobbyists thing that's on. Forget what you call it. I think it's this weekend or is it next weekend? Might be the next weekend. It's Easter weekend. So that's a big deal. It's happening at the Springvale, some place in Springvale. Okay. Who else is there? Andrew, KIS, and Wayne. All right. Thanks, chaps. This is VK3 EKH, the official station of the Astronomical Society of Victoria. Further information can be gleaned by going to the website at www.asv.org.au. In the meantime, have a lovely weekend. Stay cool. We're all cool, aren't we? So see you next week. VK3 EKH concluding transmissions. Cheers, everyone. All right, and we shall conclude transmissions here on video. And for viewers of YouTube and repeater, we'll see you all next week. Don't forget the broadcast, WIA broadcasts. Always calls me before I'm finished here. Yeah, stand by a sec, Ray. Just finishing up on the vision side of things. So, yes, cheers, everyone. Take care. Have a nice weekend. Thanks for watching. And I'll be back again to do the WIA broadcast Sunday morning at 10:30 on RTV1 and also on 9 o'clock on 1825. So if you're in the area, in this part of town, tune your broadcast receiver to 1825 AM and listen for a fat signal. This is VK3 EKH concluding transmissions on YouTube, at least for the time being. Stand by for colour bars.